So today I'm going to present about federated machine learning. I'm going to talk about machine learning in general and how it's going to fit into the Filecoin ecosystem. So before that, I'll just give a brief introduction. I did machine learning before, so generally my background is in machine learning, creating machine learning systems for enterprises across Southeast Asia. And then afterwards, I was selling like a software for machine learning. So today's agenda will be two parts. I'm going to talk about the evolution of data architecture and how it has evolved to today's data mesh. With the data mesh paradigm today, it's going to enable federated learning and also how IPFS fit into this paradigm. Following which, I will describe a bit about federated learning, what it is, the use cases of federated learning, and this new proposal from one of the articles that have been published on IEEE. This is the interplanetary learning system. It was written by some master students. So I'll be explaining what the content is. And finally, I will talk about some useful tools for scaling AI. So for those that want to get into creating AI systems, these are some of the important components for you to scale your AI. So starting off, we have this data architecture diagram. This is by Databricks. It's kind of, I can't really see it, but it started off with data warehouse. So mainly people were storing transactional data in data warehouses. Think of like legacy bank systems or like customer systems. They want to put it into data warehouses. But as time evolved, we need to store structured and semi-structured data. Semi-structured and unstructured data. So these new data give additional insights that are important for machine learning and some data science prediction models. So to move to a semi-structured and unstructured data, the current data warehouse is unable to do so because they are storing OLTP data. So to enable this OLAP layer, you will need a data lake that stores a corpus of text. And you need to run some sort of analysis on the text itself and perhaps get some sentiment analysis. Right now, the hype is to create new text from your existing corpus, generative AI. Databricks have another part on top of it. It's called the data lake house, but what it really means is that they have metadata and governance layer on top of it. There's another paradigm called I think data mesh and one more, but I'm not going to talk about the fourth one today. Today we're going to focus on data mesh and the evolution from data warehouse, data lake to data mesh. So this is how it looks like in the enterprise data architecture. You have your data sources that comes from various business entities. You ingest it into your data lake that acts as a landing zone, and then you then store the OLTP data in the data warehouse. For the data science and the machine learning layer, you interact directly with the data lake because, of course, there's different environments there. You do this because a lot of unstructured data is needed for some of the machine learning use cases that we're seeing nowadays. Following which, the data warehouse will be split into domain-specific data marts for business entities or end users to consume. So right now it's split this way. You must be wondering why I'm talking about like enterprise data architecture at this point in time. But you'll see how this evolved into the bigger ecosystem of Filecoin. Right now, enterprises are going away with this architecture, as you see right here, and they're going to move towards something something more decentralized. So so storage providers can then come into the picture and become data providers for enterprises as well. So this is another avenue stream that you can look at. So the current businesses, what they do is that all your CEOs, your domain teams will interact with a central data team. They manage your entirety of the data itself. So when you want data, you request from the central data team, which takes ages to do. And creation of this centralized data lake is actually very expensive. A project can take 2 to 3 years. And if, let's say, like a regional bank would like to create this data architecture of a centralized data lake here, it will cost around like 30 to 60 million USD just to do this in Southeast Asia itself. So they're going away with this. They do not want a centralized data team anymore. Those that have not built data lakes in the past, they have moved towards the data mesh architecture. So what this means is that your initial data lake is going to be decentralized into business domains instead. So the business owns, or at least the different departments within the enterprise owns the data. So they become domain experts in their data itself, and they're going to decentralize all this engineering team into autonomous teams. So one DevOps engineer will serve the rest of the business group. So this is actually very similar to some of the SPs on the ground as well. So as SP, if you already have a DevOps engineer and you have some data that you think is useful and can be productionized, you're already halfway there. You can then package this into a data product and sell it to enterprises in future. I'm not going to talk about like the internal of what this data mesh architecture is going to be, but within a pod or in the hub and spoke model, this spoke itself, there is this portion on the bottom left. This is the data product. I just want you guys to focus on the data product and the data contract itself. So the data contract consists of the exchanges you have with the upstream data sources. Like what have you aggregated to form this data? This will serve as an audit. This serves for audit purposes, so you can see the lineage of the data itself. So whenever this is reported to like certain authorities that you have used for machine learning, this is going to be very important. And with the data contract here, you can always swap it for a smart contract. The next one is the data product. Once you have created a data product that you think you can monetize, you now can sell this to respective enterprises that need this insight or this data to create a better insight. So the data mesh architecture in an enterprise looks like this. There are multiple layers to it. There's an aggregation layer. So, but the focal point of this would be this center portion here, this CRM, Customer 360. So to create like a holistic view of your customers to drive upsells within certain products, or like recommend the next best product to give to your customer, you might need a bunch of data here. And different SPs across different regions might be able to provide these data to create this model itself. So imagine like different SPs working with one another, providing data insights and having a data exchange, and talking to one another to create the machine learning model that perhaps some enterprise within the region might need. So if you replace these with SPs, you can probably create a data mesh or like a decentralized data exchange in a larger scale. Okay, I'm going to move towards what federated learning is and why does it have any implications with the data mesh architecture that is seen nowadays. So federated machine learning is different from the traditional paradigm. It doesn't require you to centralize all data that I mentioned earlier. You don't need to spend $30 million, 3 years, just to bring all the data together, split it into data marts, and then apply a machine learning model for you to gain value out of your insights. Federated machine learning allows you to train your model on edge devices. And these edge devices it's not only exclusive to mobile devices or laptops. This can be different SPs as well, or different storage providers. So the pros of this is that you can train your model locally. So there will be no data exchange across different storage providers or different regions. In region-specific laws that is appearing in Southeast Asia, you probably can't move data from perhaps like Indonesia or even Singapore out of the country itself. So this federated machine learning can solve some of these problems that we're experiencing right now. So in summary, traditional machine learning looks like this. On the top column, it's centralize all your data in one place through different data pipelines, train your model, and then you have insights generated out of your model. The new paradigm, however, is that you train the model on the edge device and then send the weights to a centralized server to create the model itself. So you don't really need this data exchange to happen.
What does that mean, train on the edge device? Walk me down to the hardware level and up software level.
Okay, so on the hardware level, it's, for example, like I need, for example, a camera, like a CCTV somewhere, and I'm trying to identify perhaps people of interest, people of dangerous terrorists, yeah.
Good-looking people.
Yeah, good-looking people as well. So for those cases, like you want to infer it on the edge itself, you might need to identify this individual through different features that he or she has. and that requires some level of compute in your GPU itself. So you can see like the hardware level. For example, there will be NVIDIA Jetson that's mounted onto a camera to do the inferencing part on the edge itself. So it doesn't have to transfer data all the way back to the centralized cloud server or like any on-prem server. Train it there and then push it back. By then, it might be too late. Or so the normal computer vision models that you see that just identify like this is a male or this is a female. It's not. It's possible to deploy onto the edge as well for faster inference.
So it's an embedded card?
Yep. Yes.
How much is the card?
1,002 for a simple machine learning model, SGD.
You say mounted on the camera, or it's like on the LAN environment there at the nightclub entrance?
Yeah, it's there. It's physically on the machine itself. Yeah.
And then when it needs the hot trigger, it sends the picture back.
Yeah. So it only sends a signal back. It does the inference on the edge. Yeah.
Why is this? I don't understand. Is there that much latency concern?
For critical use cases, yes, there will be latency concern. It will be too slow for that to occur. It's going to be in seconds and not even milliseconds for the inference to take place. And generally, with this generative AI thing coming along, they mentioned that training is a huge component of it, but actually inference is also a huge component of it, which I will talk about some of the toolings at the later part of the presentation itself. Yeah. So the new paradigm, coming back to this, the new paradigm actually allows you to train the model on the edge itself and then send back the weights to the centralized server to create a model. So this is federated learning. So you imagine like different devices, edge devices, or different storage providers training a model or training part of the model and sending back to this aggregation machine. So this MA plus MB plus MC is just an aggregation of the weights of the model itself. Yep. Then another picture of federated machine learning. So you can have different participants to give you the data. Of course, the data has to be the same. You have to define the parameters of the data first. So these parameters can be done in the form of a smart contract as well. But let me just talk a bit about the use cases of federated learning for you guys to perhaps understand why this is so important in the next leap of machine learning. Federated machine learning can ultimately enable autonomous vehicles for a bigger sense of their environment itself. Each vehicle can only see a limited amount of space within their peripheral vision or whatever they're sensing at the point in time. But with federated learning, you can do V2V communications. Of course, this is assuming that the network has already reached like 6G or like this is mature enough to accommodate the amount of data that needs to be transferred and at a speed to other vehicles. So the federated data set will be able to give you a much bigger awareness of the surrounding, and you can still apply like reinforcement learning on top of these vehicles to enable them to act based on certain things that they cannot see or act based on things that they know is in front of another car. So this is very important, V2V communications or V2X communications in vehicles itself. Another part that is more relevant right now is that protected health information across different hospitals are not able to send data out of their database. So in some of the projects that I did, we managed to, or at least for this project, what's happening here is that data for 20 institutes was used to train a federated learning model. It's across different countries. But they cannot move data across different countries. And this allowed us to have a holistic view of the global population and maybe like predict this outcome in patients for specific vaccines for COVID-19. So moving on from these use cases, maybe I'll just pause here for a while if there's any questions from the floor. Nope. No questions?
When you say leaving, I guess I think of data sovereignty from a camera perspective. Doesn't really work, right?
I think even for like, I'm not sure what are the laws for that, but
I guess you're already in country.
yeah, it's still in country.
But from a healthcare perspective, why would it
leave the country. So from a global scale, like COVID-19, we needed like for vaccine trials, they probably need the whole entire world's, yeah. So this to hit global optima. Like right now, if I train on the local data sets of Asians, I might only get the optimal vaccine for Asians. But
So
yeah,
what about that, that case where we saw that example of DNA sequencing,
yeah.
right, that were being tested in Australia, but it was being processed in China?
I think technically that might have some implications. I'm not sure Australia has that law, but if let's say you're in Indonesia next year, this is not going to work. It's illegal. Yeah. Right now, there's only laws for I'm not sure. Maybe the crowd would know as well on YouTube, but like right now in Asia, there's only data sovereignty for most financial institutions. Yeah.
Would you say like the federated learning model is on, like, if it has to remain in the country, but it has to utilize some heavier, we'll call it processing outside the country? There's like almost like a CDN for the
Yep.
personal information that holds the data, but the non-personal information gets sent out and comes back.
Oh, that's fine as well. If let's say you want to send a non-personal information, you want to encrypt your PII data and then send it out into a centralized server to do that, that's fine. But the data processing of that happening is also going to take time. So you're going to take 2 times the time, 2 times the duration. First, you have to bring the data out to one centralized server, and that takes, if it's petabytes, it actually takes a very long time. And then so there is the centralized data lake versus like different countries already creating these variables that is needed to train. So there are different teams working in conjunction to create just this table, and then I just send my models over, or at least send the job over for them to train it. Yeah. Yep. Yep. Oh, sorry, I can't really hear. Yeah. Central location.
I'm not loud enough. So I mean, you mentioned that the node
Yeah.
sends out the models to
Yes.
the network to
Yeah.
process. So is there a central location that process all this, or is it decentralized?
No, it's decentralized. So every single component that you send to, they'll be processing the model will be training there according to the GPU capacity it has.
So
Ultimately, yeah.
So you have different copies on the network.
Not different. Yes, you have to have different data. It's not copies, but I'm assuming that every country has different demographics of data, so the population is different. Yeah, so it's data wise, it's a bit different across different countries.
So there's no single point of failure then.
There is potential failure, and there's also potential pitfalls of this mechanism, which I will talk about later on.
Okay.
There's something called model poisoning, where you can influence the training of a model, and there might be bad actors within this, because you're essentially sending out to multiple agents, so they can be bad actors within these ecosystem as well.
Yeah, cool. And also like how the output of the
Yeah,
these models.
so you kind of have to check it, and it needs an immutable layer, to be really honest.
Yeah.
Yeah.
Cool. Okay. Thanks.
So then further down, I will talk about blockchain and and yeah.
Thanks.
So I'm going to talk about this paper that published IPLS. So IPLS is a paper or this vision that is written by a group of students, and they are envisioning a learning layer on top of IPFS. So in traditional centralized federated learning, there can be different ways of federated learning. This one flavor that they have presented as more centralized, where different actors, okay, see these individual people here, we're going to send the model to them, and they are going to train it locally. And they're going to aggregate the weights of the model back into a centralized server to create that model of a holistic view. In the second part, I think you can't really see this, but every agent is responsible for some parts of the model. So this is more of like the aggregation of different weights, and these different individuals will start training. But other than that, they will do like a round trip. So for example, actor 1, they will talk to actor 2, and they will kind of aggregate and cross-pollinate before they send the model back to to the one requesting for it. And at any one point of time, people can participate in this training. So it creates this holistic system of people having data and able to contribute to the performance of a model itself. The IPLS is built on top of IPFS, and it has they propose 4 API methods. First is to initialize and then update the model, load the model or terminate it. So, but generally, like this is a very basic decentralized network that they experimented with. This is by no means still federated learning is still a nascent field. So they are still trying to optimize certain things about it. So before I talk about the flaws, you can see that the decentralized of the 50 agents, the one with the circular dots, is actually not performing as well as the one with a centralized agent. So even though even with data sovereignty, you can solve issues like that, there's still this issue of not being performant because of certain network conditions, certain people sabotaging the training, the training of the model. So some of the flaws include bad network connectivity, the lack of an incentive layer, so not many people will want to join the training, and the final one last part, model poisoning. Of course, this is not conclusive of everything. There are a lot of things that still need to be fixed within federated learning to enable this portion. But I'm just going to talk about model poisoning first. So in training, you can sabotage the training of a model itself by saying that cat is a dog. So imagine this training occurs on the top part, and you're supposed to inference that a cat is a cat. But if you label a you label a picture wrongly and you keep training it and say that a cat is a dog, then it will infer it as a dog. So you can sabotage the training of model in terms of a decentralized network and become the bad actor, so that your model will not be performant or they will infer the wrong things for your own benefit. There are some solutions to this. What I can think of right now is to create an immutable layer so everyone is responsible and they know exactly who is the bad actor. And also create an incentive layer to ensure that more people participate in this training and to so that the inference will be accurate. Yeah, I'm coming to the last part of my AI portion. There are certain traditional Web 2 tools that you can use right now for scaling of AI. We can see some of our ecosystem building on top of these as well. So the first one I'm going to introduce is Ray.io. This is one of the platform that has been used to train ChatGPT. OpenScale uses behind the scenes, or the managed version of this is AnyScale. But what it does is that I want to highlight here is that it has native support for CPU as well. So although the training is not that great, if you have a 32 core Threadripper or an Epic sitting around, you can still train your model on CPU. So I think during one of my studies, I didn't have enough. There was a GPU shortage. So I had to use Ray to train it on my CPU instead. It took a lot longer, but it's still possible to do so. And Ray can potentially do cross-regional training as well. You can initialize a job elsewhere in the world and train your models. The other one is a federated learning open source framework that I use quite a lot. You can define the amount of clients you want to train on as well. That's assuming you have 10 clients available. And then finally is the inference part. So this is a part that I think a lot of people are missing out. It's not only the training of the model that's very GPU intensive. Inference using a very big neural network is also very GPU intensive. The reason why I put this picture at the bottom left-hand corner is the tensor core section. So with Triton Inference Server, you can segment portions of your tensor core to serve different models, so you can better utilize your GPUs as well. Underneath the hood, there's also multiple libraries that work together with NVIDIA's Triton Inference Server. This is not an advertisement, but mainly, I think most of the software right now is on the NVIDIA stack.